So today we have easy problem to reverse bits in an integer. Given some integer in its binary representation, we want to reverse. So it became like this. The solution is, let's look at my code. I just look on every bit in a loop and I check if this current bit is set, and if it's set I reverse the position of the bit and then set it in a result. So we'll go and looking at this bit, and to look at this bit we have bit position b and let's say shift right. B is this one. Then we do like and 1, and this is 1. This checks the current bit. Now if it is set, I use this B position, and B 31 minus B is this position. So it's like mirror this position. And now I set this bit to the result. So result is result or this bit. And how can I make this bit? I use and shift left 31 minus B. This is how I set this bit. Now this is a trivial implementation. We have some other people made much clever implementations, like using bit hacks with masks and so on, but I think this is problem would be overhead for this problem. This problem has a follow-up. If function is called many times, how would you optimize it? The possible answer to this question: first you optimize the internals of this function, like using bit masks. There is many possible ways to optimize, but after that you have to do the caching. For example, you do some tables lookups. It would be a little bit faster if we compare it to some 30 operations. Now let's look at the golf implementation. I would use integer reverse as the most optimal one, because the library would always optimize its internals. I would hope so. Now the other different one-liners is like use the sum of instead of or. It allows us to shave some letters from the answer. Now the string implementation, it can be bad start, it can be bad end, and the fold implementation is just a loop that rewritten into the fold. Now let's look at the Rust. The Rust is kind of more helpful in this time than the Kotlin, because it allows us to expose renaming of the method. So we use const the method signature, and we just use a built-in reverse bits. So it's kind of nice. And the other solution is trivial to map sum as we did in Kotlin. So that's it for today.